Today we're talking about simplifying radicals and rationalizing denominators. First, let's start by simplifying radicals. What a radical is the square root symbol with the number. But we have specific names that we call each of these. The square root symbol is what we call the radical. And the number that's under the radical is what we call the radicand. So what we're looking at is simplifying the radical. We don't want it to say the square root of 64 because 64 can be broken down into different numbers. Now, 64 does have a perfect square, but I used it so I can show you that the way that it can be broken down. We know the factors of 64 are 8 and 8. When we're simplifying radicals, once we have two numbers that are the same thing, I like to circle them. If they're circled, that means I'm going to make them go outside of our radical. They're no longer under the square root. And so the answer to this is the square root of 64 is 8. So let's try that method on the next problem. This next problem asks us to find the square root of 147. Now, I don't know the factors of 147 right off the top of my head, so you can always start with low numbers, 2, 3, 4, 5, 6, 7, 8, and 9. I'll start at the bottom with 2. I know 2 doesn't divide evenly into 147, so then I try 3, and I find that 3 divides evenly with 49. So my factors of 147 are 49 and 3. Then I carry on and say 3 can't go any further, but 49 can be factored to be 7 and 7. Here we have a matching pair, and we have 3 left over. If we have a matching pair like we do with 7, it goes outside of the radical, and so our answer of a simplified radical of the square root of 147 is 7 square root of 3, because that is what was left over. Let's look at the next example of the square root of 72. We break it down into its factors. We know that 8 times 9 gives us 72. My factors of 9 are 3 and 3, and once I've broke my factors down to their prime factors, I mark them out. I know 8 can be factored into 4 and 2, and then I know 4 can be factored into 2 and 2. I match them up. I have 2 2s and 2 3s. Those are what go outside of the radical, and so I have 2 times 3, and then I had this 2 left over. It stays underneath the radical. 2 times 3 is 6, and I can't do anything with what's left, so I leave it as the square root of 2. So my answer here is 6 square root of 2. The square root of 150. Well, I know the factors of 150 are 15 and 10. I also know that 30 will go into there with 5. So you can use different factors. You should get the same answer. So let's just look from 15 and 10. I know 15 breaks into 5 and 3. I know 10 breaks down into 5 and 2. All those are prime numbers. I have 2 5s, then I have a 3 and a 2. The 5 goes outside of the radical. Then I have the square root of my other two numbers that are left, 3 times 2. So that will leave me with 5 square root of 6, because I multiply these two together to get 6. The next problem is the factors of 80, or what's the square root of 80? I know this breaks down into 8 and 10, factors to 8 and 10. The factors of 8 are 2 and 4. Let me fix that 4. The factors of 10 are 2 and 5. Now, from this step, we found a pair, which is 2 and 2. And I'm looking at 4 and 5. 5 can't break down any further, but 4 can. 4 can be factored to be 2 and 2. So I have another pair. So I have a 2, another 2, and then we're left with 5 underneath the radical. So 2 times 2 is 4 times the square root of 5. Our next problem, the square root of 192. If you look at your multiplication chart that goes up to 20, we can find that 192 is a result of 16 and 12. So our factors are 16 and 12. Those can be simplified down to their factors. 16 is 4 times 4. 12 is 3 times 4. If you'll notice, we have a pair of 4s. Three can't be factored, but 4 can, to be 2 and 2. So we factored 12 and we factored 4. And if you notice, we have a pair of 2s. So the 4 and the 2 go outside of the radical. 4 times 2 times the square root of what's left. We had a 3. 4 times 2 is 8 times the square root of 3. And that's your answer. Examples. The first one is 216. Again, we can look at our multiplication chart or factors chart and find that 18 times 12 equals 216. There may be a few other ones, but we'll work with 18 and 12. And I look and see, what are my factors of 18? We know 2 and 9. And what are my factors of 12? 3 and 4. 2 is a prime number. 9 is not. 9 can be factored to be 3 and 3. 3 is a prime number. And 4 can be factored into 2 and 2. Start looking for pairs. We have 2 sets of 3 and 2 12s. And we have a 2 left over and a 3 left over. So when we have pairs, those go outside of the radical. We have a 3 and we have a 2, so 3 times 2 times the square root of the numbers we have left that didn't have pairs. 2 times 3 under the radical. 3 times 2 is 6 times the square root of 2 times 3, which is 6. So our answer is 6 square root of 6. And our last example is square root of 384. If you don't have that number on your multiplication chart, start with the low numbers, 2, 3, 4, 5, 6, 7, or 8. Or choose the number that's at the end of the radicand and divide by it and see if it comes out with an even number. This one actually does. Our factors of 384 are 96 and 4. Now we can factor 4 to be 2 and 2. And we can factor 96 to be 12 and 8. 12 will factor to be 3 and 4, and 8 will factor to be 4 and 2. If you notice, we have 2 4s, we have 2 2s. So we have a 4 and a 2 on the outside, which is 8, because it's 4 times 2. And then our square root is 3 times 2, which will be the square root of 6. So your answer should be 8 square root of 6. If you need to, pause the video and take a short brain break to give your mind some rest, because we're going to move on to something different in just a few seconds. Now we're going to look at rationalizing denominators. When we rationalize denominators, it's because there's a radical in the denominator of a fraction. Radicals mathematically can never be in the denominator. It's just a mathematical rule. So the way to solve this, or to fix this problem, is we multiply by 1 in a creative way. If you remember, anything over itself in a fraction is equal to 1. 1 over 1 equals 1. 2 over 2 equals 1. 5 over 5 equals 1. 387 over 387 equals 1. Square root of 5 over the square root of 5 equals 1. So let's look at this in action. So our first example says 2 over the square root of 5. Remember, this is incorrect because it's over the square root of 5. The square root of 5 is a denominator in this fraction, and that is not mathematically correct. So we have to multiply by 1 in a creative way. Our fraction, however, tells us what we're going to multiply by, or what our fraction, our creative fraction of 1 is going to be. It's going to be the square root of 5 over the square root of 5. When you're multiplying fractions, you multiply straight across. So 2 times the square root of 5 would just be 2 square root of 5 over the square root of 5 times the square root of 5, which is 25, the square root of 25. And you know what the square root of 25 is. That's 5. So on top we have 2 square root of 5. In the denominator we have 5. That would be your answer. So really what happens when we multiply the square root of 5 by the square root of 5, the square root symbol, the radical, cancels out. And so if you know you're multiplying the square root of 5 by the square root of 5, you get 5. It can be any number that you have underneath the square root symbol. As long as you multiply it by yourself, you're going to get that number. So let's look at a few more examples. 6 over the square root of 3. So again, we're going to multiply by 1 in a creative way. The square root of 3 over the square root of 3, because that's what our denominator is right here. We're going to multiply straight across. 6 times the square root of 3 is 6 square root of 3. The square root of 3 times the square root of 3 is 3. And this looks pretty easy, but look, you have 6 divided by 3 right here. If you can, you must simplify. 6 divided by 3 is 2, and we have the square root of 3 left. So our answer is 2 square root of 3. The next problem, 1 over the square root of 2. Our denominator is the square root of 2, so that's what our fraction is going to be, the square root of 2 over the square root of 2. Multiply straight across. 1 times the square root of 2 is the square root of 2. The square root of 2 times the square root of 2 is just 2. And we are done. The next problem looks a little bit tricky, but still stick with the same method we've been using. What's our denominator? It's the square root of 2. So we're going to multiply by 1 in a creative way. The square root of 2 over the square root of 2. Multiply straight across. Here it's easiest to start on the bottom. The square root of 2 times the square root of 2, remember, gives us 2. Then we need to multiply the square root of 3 and the square root of 2 together. The square root of 3 times the square root of 2, you multiply 3 and 2, and that gives you the square root of 6. The 6 can't be multiplied in on the outside, so it stays here, and we have 6 square root of 6. Looking at what we have, we can simplify or divide 6 and 2. 6 divided by 2 is 3, and then we have the square root of 6. So 3 square root of 6 is our answer. The next problem is 7 over the square root of 14. So we multiply by the square root of 14 over the square root of 14. Multiply straight across. You have 7 square root of 14 over 14. Again, you have a fraction that you can simplify. 7 over 14 is equal to 1 over 2. So we have 1 times the square root of 14 over 2. But we don't have to write this one because it's understood. So really, our answer is the square root of 14 over 2. The next problem, 10 over the square root of 5. We're going to multiply by the square root of 5 over the square root of 5. Multiply straight across. We have 10 square root of 5 over 5. Again, you can divide. 10 divided by 5 is 2 with the square root of 5. So our answer is 2 times the square root of 5. The next problem, I threw a little trickeration at you. There's no denominator in the bottom, but you can simplify. 8 divided by 2 is 4. So really the answer here is 4 square root of 2. And our last example, you have 9 times the square root of 5 over the square root of 3. Remember, we're going to multiply by what our denominator is made into a fraction. So it's going to be the square root of 3 times the square root of 3. Multiply straight across. The denominator will be 3. Our numerator will be the square root of 5 times the square root of 3 with 9. So 9 square root of 5 times the square root of 3. 5 times 3 is 15. So it's 9 square root of 15 divided by 3. You can divide the 9 and 3. 9 divided by 3 is 3 square root of 15. And you're done. That concludes our notes for today. If you have any questions, please do not hesitate to email me. But I do want to leave you with a little reminder. Remember, we don't want to find the square root of something by plugging it into a calculator, such as the square root of 12, because we're going to get a decimal to round, that we'll have to round. That's why we simplify into the fractions, or that's why we simplify radicals. That's why we want to write it like as we've practiced, 2 square root of 3. This is the simplified version. We don't want a decimal because we would have to round. This gives me a more correct answer. Again, if you have any questions, please don't hesitate to email me.